students, till now we have discussed about kinematics of one-dimensional motion. Now in this lecture, I would like to discuss a little bit about graphical analysis and how to apply that graphical analysis to one-dimensional motion. First of all, do you remember your graphical analysis from your previous classes? We will plot a graph between x parameter and y parameter. X represents a physical parameter, y represents a physical parameter in physics analysis. For example, on x-axis I can take time, on y-axis I can take velocity. Then through graph I am trying to understand how velocity is changing with the time. If I understand how velocity is changing with the time, I can estimate the value of acceleration, because change in velocity per unit time will give you the acceleration value. So in order to find out the physical parameters, we will make use of graphical analysis, because while discussing physics analysis with respect to time, you can speak out with respect to time at one instant only with the help of an equation. For example, if I use v equal to u plus at, if I substitute t equal to 1 second, I can get the information of the velocity only at t equal to 1 second. It is not possible to have a look at all velocities possible at all timings, isn't it? That is not possible with the help of single equation. But all that information consolidated over a graph with the help of graphical analysis. Observe, I can have all possible timings on x-axis, all possible velocities on y-axis. I can look at the graph and I can get all the information at a time. That's why graphical analysis is very important for us. We can represent a very large amount of information within single graph. That's why, anyway, the most simplest graph that you know from your previous classes is a straight line passing through the origin. It is passing through the origin. Origin means x coordinate will be 0, y coordinate will be 0. Every graph will be characterized by its slope. What do you mean by slope? If theta is the angle made by the graph with respect to positive x-axis, slope of the graph will be given by tangent of the angle made with positive x-axis. Probably you may know that if I take a situation between the x coordinate and y coordinate like this, have you observed the difference between these two cases? This graph is making an angle theta less than 90 degrees with respect to x-axis, and this graph is making an angle theta greater than 90 degrees with respect to positive x-axis. If theta is less than 90 degrees, tan theta will be positive. So slope will be positive for this graph, slope will be negative for this graph. Whenever theta is greater than 90 degrees, slope will be negative. Hence, this graph represents positive slope, and this graph represents a graph with negative slope. That is one information that we can get. Next thing is how to calculate slope. You observe. Let us suppose I know an x1 value and another x2 value. I have taken an interval of x1 and x2. Corresponding to x1, the value on y-axis is y1, let us say, and corresponding to x2, the value on y-axis is y2, let us say. Is it okay? This value or this length will be x2 minus x1, and this length will be y2 minus y1. If this angle is theta, if I draw a horizontal line here, if this is theta, this is also theta. Then this length is x2 minus x1, this length is y2 minus y1. We know, according to our previous knowledge, tan theta for this triangle will be opposite side divided by adjacent side. So tan theta can be found from y2 minus y1 by x2 minus x1. That is how you can find out slope of a graph. Here also you can find out very easily in the similar fashion. What makes the difference between this graph and this graph? While x is increasing in this graph, y value is increasing. Have you observed? If x2 is greater than x1, y2 will be greater than y1. Means if theta is such that positive slope is there, y increases with x in this case. Whereas in this case, have you observed? If x is increasing, y value is decreasing. Y value is decreasing. So whichever the graph is having negative slope, for that, if x increases, y value is decreasing. Sometimes any graph can be represented with the help of some equation. How to represent? You see, fortunately, this graph is passing through origin. In order to represent this graph with the help of an equation, what I will do is, I will take up one general point on the graph and the other known point on the same graph. You observe? I am taking one general point on the graph. Let us say this is the general point which will give you x comma y, and the other point through which it is passing will be 0 comma 0. Do you observe? This length will be y, this length will be x, implies tan theta will be equal to opposite side y divided by adjacent side x, implies y will be equal to tan theta, which is a slope, will be represented with the help of a letter m. So y will be equal to mx is the graphical equation for this particular graph. Next, sometimes the graph may not pass through the origin. In those situations, how to draw the graph equation is also important. For example, say this is x-axis and y-axis. Let us say the graph is a straight line which is passing through like that. Have you observed? It is not passing through origin, but at this point x value is 0 and y value is some c. What is y value here? This length will be y value. Is it okay? Then, in order to find out this graph equation, what I will do is, I will take up one general point. That general point is x comma y, and one point through which the graph is passing through. This angle, I will indicate it as theta. Now, I will write down the expression for slope. Slope tan theta in that case will be opposite side divided by adjacent side. How much is opposite side? This length will be opposite side for the triangle. This total length is y. This length will be c. How much will be this length? This length will be equal to y minus c. We know already this length is x coordinate, which will be x. Means this length will be x. You apply tan theta. Tan theta will be equal to opposite side y minus c divided by adjacent side x, implies tan theta can be written as m, which is known as the slope of the graph, which will be y minus c by x, implies y equal to mx plus c is this graph straight line equation. So, if the straight line is passing through the origin, you can represent it as y equal to mx. If the straight line is not passing through the origin, you can represent it as y equal to mx plus c. Actually, what slope signifies is also very important for us. For example, while making a comparison between two graphs, If one graph is having more slope, what it actually represents and what properties it will get. Understanding that also very important. Say I will show you as an example. I have two graphs, x and y. As a simple case, I will take up both of them to be passing through origin. One is making theta 1 angle with the positive x-axis, other one is making theta 2 angle. Clearly, theta 2 is greater than theta 1, implies tan theta 2 will be greater than tan theta 1, implies m2 will be greater than m1. This rule is applicable when both the thetas are less than 90 degrees. In order to understand the properties of these two, what I will do is, I will take up two positions on x-axis, x1 and x2. You observe corresponding y interval. Let us say this is x interval, delta x. For graph 1, I am indicating this as y interval, delta y1. I am extending same x values. And corresponding y interval I am taking on second graph. This is second graph. This will be delta y2. Have you observed? But the same x interval, y interval will be more on second graph as compared to the first graph. Y interval is more means y coordinate or y parameter is changing more rapidly on second graph as compared to the first graph. Means whichever the graph is having more slope, on that y parameter changes very rapidly as compared to the graph which is having less slope. One is having less slope, that's why y interval will be lesser here, and second is having more slope, that's why y interval will be larger as compared to x interval. So delta x is the same, but theta 2 is greater than theta 1, implies delta y2 is greater than delta y1. That is one more thing to be remembered.